Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic chapter 8, reading done part 2. Our today's lecture number 29 and SW number 26. So let's start our class. This is chapter 8, reflection of light. Now we will discuss image. When you stand in front of a mirror, you will see your own image, and the closer you stand, the image seems to appear the same distance behind the mirror. Now we will discuss this question. Show that triangle OPX and OPX are congruent. Here angle XPO equals to angle X dash PO, because both of you are right angle and XP is normal. Here XP is the normal to the plane. According to the laws of reflection, incident angle is equal to the angle of reflection, and therefore angle XOP equals to angle ROA. Again angle ROA equals to angle XOP, and therefore between triangle OPX and OPX dash, OP is the common arm and two angles on both sides are equal, so triangles are congruent, and therefore XP equals to X dash P. The image we see in a mirror is not equally real even though it seems real, and this is because light is not actually coming from the place it appears to be coming. Later we will see that sometimes images are really formed by converging light and light rays come from there. This type of image is called real image, and it is possible to do many things with this type of image. In case of the image formed in a mirror, light does not actually come from the image, so this is virtual image. And see this figure. Here shows how an image is formed for an extended object instead of a single point, and light coming from points X, light coming from point X and Y from the mirror, and this is the mirror, light coming from X and Y from the mirror and form a virtual image at the point X dash and Y dash. That means X dash and Y dash are the image of object X, Y. So you can clearly see that the length of xy and is equal to the length of x dash y dash. So if the arrow head of xy is on top and arrow head of x dash y dash will also along on the top. That means from this figure we can say, so image in a mirror is equidistant from the mirror, and equidistant from the mirror, and number B, it is this image is virtual, number C, this is straight, and number D equal to the size of the object. Okay, now we are reminding this separately, because later we will find that if we use mirrors of other types instead of plane mirror, the image may form at different distance, may be real, may be inverted, and may even be small or large. My dear students, now we will discuss spherical mirror. We all have seen ordinary plane mirrors, but not have seen a real spherical mirror. But the main concept of a spherical mirror can be seen in a new shiny spoon. See this figure. This is the new shiny spoon. Spherical mirrors are of two types. Okay, my dear students, spherical mirrors are of two types, concave mirror and convex mirror, and we can make concave or convex mirror by cutting a portion of hollow sphere and coating its surface with the silver or aluminum layer, and whether the spherical mirror will be concave or convex depends on which surface is coated with silver or aluminum. So now come to convex mirror. Now we will discuss convex mirror, and we have already learned spherical mirror are of two types, concave and convex mirror. An actual convex mirror is a part of real sphere, and let the radius of the sphere be r. Okay, suppose this is r, a part of it has been cut to make provision for reflection of light from the convex side. If a parallel light beam is incident on the mirror, the light will scatter in all directions. My dear students, see this figure. This is a convex mirror, and if parallel light coming incident to the on the mirror, then the light will scattered in the all the direction. And if we extend the scattered light towards the center of the mirror, if we extend this scattered light with the towards the center of the mirror, it seems like they have come from a point, this point, and this point is called focal point. The center point of the surface is convex mirror that reflects light is called pole, and the distance of the focal point from the pole, distance from the focal point to the pole is called the focal length, and we indicated by focal length small f, by small f. We can imagine a spherical mirror as a part of a sphere, and if the radius of the sphere is r, its focal length would be r divided by 2. My dear students, now we will discuss this topic. Prove that f equals to r divided by 2. Here f is focal length and r is the radius of the sphere. Okay, and this one is very important question also. Prove that f equals to r divided by 2. Answer will be, interestingly, you cannot prove this completely, and you can only go close to it. Lay two rays parallel with the principal axis of a spherical mirror. Come from spherical mirror, then come from A and B respectively, and the first ray has come to point X. This is XY, this is the spherical convex mirror, and the first ray has been come to point X, and the second ray has been come to the point Y. The ray coming point X will be reflected back, it has come. Okay, the ray coming from this point, it will be also reflected on this way, and let us extended this ray to the center of the sphere, that is O, and we can see that OX equals to R. This is the radius of the R, and the ray coming from point B, to the point Y will create an angle of incident theta I with the perpendicular ON. Okay, perpendicular, this is perpendicular ON at the point. The angle of reflection of the ray BY is theta R, and it will be reflected towards YP. See, this is YP. Okay, and if we extend PY, it would be intersect line OX at point F. So FO equals to FY, because in the triangle of OFY, and angle FOY equals to angle OYF as FOY equals to theta I, that means this is the angle of incident, and angle FYO equals to theta R, this is the angle of reflection. So FOI is congruent to Fx. So Fy is congruent to Fx, and when xy is small compared to radius r, this is true for most convex mirror, and so Fy equals to Fo equals to Fx equals to r divided by 2. So focal length f equals to r divided by 2. This is proved. Okay, my dear students, practice properly this question. F equals to r divided by 2. Now there is a question, if a plane mirror is considered a spherical convex mirror, then what is the focal length? Its focal length will be infinite. Okay, now come to image in a spherical convex mirror. Spherical convex mirror, we have already said that the outer part of a spoon acts as a spherical convex mirror. Okay, the outer part of the spoon acts as a spherical convex mirror, and you can see an upright and a small image of yourself here, and this means that is the image in a convex mirror should be always small. Okay, to understand how an image be formed in a spherical convex mirror, we first need to understand how light rays reflect on such a mirror. This depends on what angle the light rays are incident on the mirror, and if we know the rules of the reflection of only 3 spherical light rays, we can easily explain how an image is formed. Number 1, if light rays are traveling towards the center. My dear students, these 3 rules you have to memorize properly. If light rays are traveling towards the center, that means these figures is suppose xn or yr ray. If light rays are traveling towards the center, they are reflected perpendicularly and go back along the line they are as incident on. Number 2, if light rays travel parallel to the principal axis, they will appear to have diverged from the focal point F. And number 3, if the direction of the light ray is changed, it goes back to the way it has come. And when the light ray is traveling towards the focus, it will be reflected parallel to principal axis. Okay, so you have to memorize these 3 rules. Okay, and we can now create an image using these 3 rules. And in this figure, an object x, y, this is the object x, y is kept in front of a convex mirror. This one is a convex mirror, and x, y is the object. The light ray traveling from point y towards r, traveling from point y towards r to, will be reflected back along the same path. Okay, same path towards y, which means the image of point y will be created somewhere along the line YO. And to know exactly where the image is formed, we have to draw another light ray from the point x is another direction, but that is not necessary because we will find it by knowing where the image of point x is formed. And to find the image of the point x, we have to draw 2 rays, one by connecting to the point x, and as we have to done before, as the yr ray was reflected back to the point y. Similarly, this ray will be reflected back towards x from the point n on the mirror, and the second ray can be drawn parallel to yr, which will be the incident on point P of the mirror and will appear to have diverged from point F. So, join the line FP and extend it towards Q. So, join the line FP and extend it towards Q. Now, the line FP intersects on line OX. The line FP intersects on the line OX and at the point of X dash. At the point of X dash, and that is the image of the point X will be formed on the point X dash. The perpendicular drawn from X dash to Y will intersect line OY at Y dash, and since it appears that the reflection of X is coming from point X dash, similarly it will appear the reflection of Y is coming Y dash, and hence X dash Y dash will be the image of XY. So, the X dash Y dash will be the image of XY. And we can observe that x dash y dash is always smaller than xy, and the further xy is from the convex mirror. So, the smaller x dash y dash will get, and one should know how to draw the image of an object placed in front of a concave or convex mirror using the laws of reflection. It is very important procedure in physics. So, it is clear that actually no light is coming from x dash y dash, it just appears that the image is there, and hence it is a virtual image. Okay. So, comparing this with the image formed by a plane mirror, we can see that number A, the position of this image will be between the focus and the pole of the mirror. This position will be in the focus and the pole of the mirror, and the further the object is, the closer the image to the focus. Number B, the image is virtual, this image is upright, and number D, the image is small. Okay. Now, we will discuss about concave mirror. Okay. The inner side of a shiny spoon is an example of concave mirror. Okay. My dear students, we have already learned that the outer side of the sphere a convex mirror, and the inner side of the shiny spoon is an example of concave mirror. And those of you have looked at the inner side of a spoon must have noticed that the image is small, and the interesting thing is it is the inverted, this image is inverted. Okay, my dear students, now we will discuss this part. If the you can see that the outer part of the spoon works at a convex mirror and the inside is works in concave mirror. A real concave mirror is actually a part of a sphere, and in the case of a convex mirror, light was reflected from the outside convex shape, and in the case of concave mirror, light will be reflected from the inside concave shape. Now, if the parallel rays are connected, these parallel rays are incident on a concave mirror. This one is a concave mirror. So, if the parallel light rays incident on a concave mirror, the light rays will converge at a point. Okay, they are converge at a point, and at a point after reflection, and you can understand that this point is focal point. Okay, this one is focal point of the concave mirror, and the distance from the pole to this point is known as focal distance, and light rays don't have any option to stopping. So after converging at a point, they will travel straight forward. It will look like the diverging from the point, and therefore before reaching the focal point at the rays converging, and after reaching the focal point the rays are diverging. Okay. Now, another question, if we imagine a plane mirror as a spherical concave mirror, so what will be the focal distance? And focal distance will be infinite. My dear students, our today's SW number is 26, and MCQ, make 5 MCQ as your SW. My dear students, I hope all of you have understood our today's topic. Practice properly at home, take preparation for half yearly examination. See you again in the next class. Allah Hafiz.